Hey everybody, it is Unit 13, Day 3. It's Wednesday, 4/29. If you could have out your Unit 13 note packet to page 6, and you're going to need a reference table because you're going to be learning a new reference table today, which is reference table M. So please make sure you have out reference table M in front of you. When you're done with this notes video, you're going to complete the skill check on indicators, which will be due by 11:59 tomorrow, which is Thursday, 4:30. A reminder that your Intro to Acids and Bases skill check is due tonight. So that was from yesterday. It had to do with properties of acids and bases along with identifying electrolytes. Hey, look, it's me, except all day, even on Zoom meetings with Mrs. Wisby and everyone else. Okay, so you want to have your note packet out to page 6. We crossed off the 2 practice problems on the top of page 6, so don't worry about those. We're moving on to indicators. And you probably have used an indicator before, maybe litmus paper, maybe you did in biology, but what exactly is an indicator? Well, an indicator is used to test the pH of a substance. We're going to get into pH a little bit later on, but pH tells you if something's an acid, a base, if it's neutral. It tells you how strong of an acid, how weak of an acid, or how strong of a base and how weak of a base. But an indicator can be used to test the pH. It can tell us kind of what range it is. Now, this is a valuable tool because the acid form and the base form have different colors when they are put into an indicator solution. So there's going to be different colors involved. Each indicator has a distinct color at the end of a useful range, and it passes through an intermediate region that is a mixture of the 2 colors. So as a recap, because this is always a doozy for people, red plus blue makes purple. Blue plus yellow makes green. And then when you have red and yellow, you get orange. I'm so slow today. I even had to think about that. I'm not going to even lie. Just remember that you need to know your mixtures of your colors. There's also something called a universal indicator that if we were in class, would we be using this? This would be colored. But a universal indicator is a mixture of indicators. So a mixture of indicators that works over a wide range. So that works over a wide range. Now, there's a number of indicators that we use in class. We would use the universal indicator. There's also something called methyl orange. There's something called phenolphthalein, which is a fun word to use. There is a substance called bromethymol blue. There's thymol green. There's a bunch of different indicators that are out there. And if we were in class, we'd be using those indicators to display a range of pHs. So here's kind of an example of how this works. So methyl orange, it changes different colors based on the pH. And we're going to go over a table that's going to help us with this. But notice if the pH is less than 3, methyl orange is red. If it's in between 3 and 4.4, it's orange. And if it's above 4.4, it's yellow. So a mixture of red and yellow makes orange, which is that in-between kind of color right there. So depending on the pH, it's a different color. Notice phenolphthalein. If the substance is anywhere from a pH of 0 to a pH of 8, it's going to be colorless. Once you get to 8.2 and between 10, it's kind of a light pink. And then after you reach a pH of 10, it's a dark pink. So there's a range of pHs over which it works over and which different colors will change. All right, so have your notes out to page 7 now. This is where we're going to get into how to actually use table M, which explains common acid-base indicators. So on table M, the first column are the names of your indicators. So we have methyl orange, bromethymol blue, phenolphthalein, litmus, bromcresol green, and thymol blue. In the middle column, we have a pH range for color changes. And then on the right column are color changes. So let's kind of go over how this works using methyl orange. So how you read this is methyl orange if the pH is less than the number on the left. So the number on the left here is 3.1. Then your substance will be the color on the left in the color category. So say for instance, I have a pH of 2.2. That's less than 3.1, so less than the number on the left. It's the color on the left, so it's red. If your pH falls in between these 2 pH values, so in between 3.1 and 4.4, Let's say your pH is 4. It's a mixture of the two colors. Red plus yellow makes orange, so it would be orange. If your pH that you're given is greater than 4.4, it's going to be the color on the right. So if it's greater than the pH on the right, it's the color on the right. So if it was 5, it'd be yellow. So each indicator is most useful in the pH range of color change. Now what I mean by that, you would not want to use methyl orange to distinguish something that's a pH of 7 from something that's a pH of 9. Now why? Well, if something is a pH of 7, it's greater than 4.4. If it's greater than the number on the right, it's the color on the right, so it'd be yellow. So pH 7 would be yellow. And this is for methyl orange. What about if I had a pH of 9 and it was methyl orange was put in there? Well, 9 is greater than 4.4, so it's greater than the color on the right, or excuse me, greater than the pH on the right, so it's going to be the color on the right. So a pH of 9 will also be yellow. So you wouldn't want to use methyl orange to distinguish those pHs because they're going to be the same color and you're not going to be able to tell which is which. So that's what I mean by each has a useful color range. And right here, we're going to kind of summarize what I just said. Methyl orange is our first indicator. So it is red in a pH that is less than 3.1. So if it's less than the pH on the left, it's the color on the left. So it's red in a pH is less than 3.1. If the pH is between 3.1 and 4.4, it's a mixture of your two colors. So red plus yellow makes orange. So it's orange if the pH is between 3.1 and 4.4. And if it's greater than this pH on the right, it will be the color on the right. So if the pH is greater than 4.4, it will be yellow. And those same rules apply for each of these. So let's take litmus, for example. If you have a pH less than 4.5, it's red. If it's between 4.5 and 8.3, it's a mixture of these two, which is purple. If it's greater than 8.3, it's blue. So you just got to figure out, is it less than the number on the left? Then it's the color on the left. If it's in between, it's a mixture. If it's greater than the number on the right, it's the color on the right. And you can apply that rule for all of these. So what we're going to do is we're going to do a couple practice problems on the bottom, applying table M. So I took kind of a snapshot of table M over here. So let's say we had methyl orange and our pH was 6, and we want to know what color it will be. So here's methyl orange. 6 is greater than the number on the right. So that means it's going to be the color on the right. So it would be yellow. All right. Example number 2, bromethymol blue in a pH of 2. So here's bromethymol blue. A pH of 2 is less than 6. So it's going to be yellow because it's less than the number on the left. It's the color on the left. Phenolphthalein at a pH of 7. Let's go, here's phenolphthalein. 7 is less than 8. So it's less than the number on the left. So it's going to be the color on the left, which is colorless. It would be clear or like a cloudy white. Litmus paper at a pH of 3. Here's litmus. 3 is less than 4.5, so it would be less than the number on the left, so it's the color on the left. It's red. Thymol blue at a pH of 7. Here's thymol blue. 7 is less than 8, so it's less than the number on the left, so it's the color on the left, so yellow. Let's do methyl orange at 2.2. That's less than 3.1, so it's going to be red because it's less than the number on the left. It's the color on the left. Bromethymol blue at 8.2. So here's bromethymol blue. 8.2 is greater than 7.6. So it's greater than the number on the right. It's that color on the right, so it is blue. And then finally, phenolphthalein at a pH of 10. Here's phenolphthalein. 10 is greater than 9, so it's greater than the number on the right, so it's the color on the right. So it would be a bright pink. Just remember those rules. If your pH is less than the number on the left, it's the color on the left. If it's in between those two numbers, it's a mixture of the two colors. If it's greater than the number on the right, it's the color on the right. So now that you know a little bit about indicators, you're going to do the skill check that will be due tomorrow. If you have any questions, please post it in the discussion post. Bye.